Hello everyone. Welcome to Enjoying Math YouTube channel. My name is Kanhi Chu and I'm an assistant professor of mathematics at Texas State University. Today, I'm excited to introduce a new learning series titled 기대수, which means From Basics to Graduate Mathematics. This series is designed to help you to build a deep systematic understanding of mathematics, starting from the very foundations all the way to advanced topics at the graduate level. This series is meant to serve as a bridge to any advanced mathematical direction you might pursue, whether it is analysis, algebra, topology, geometry, or applied mathematics. A core objective is to understand how the fundamental theorem of calculus in single variable calculus is abstracted and generalized through multivariable analysis and linear algebra. In South Korea, the Gidesu series has already run 4 cohorts of study groups, with a fifth planned for later this year of 2025. Now we are working to create English language content and study groups to expand this opportunity internationally. Our journey begins with set theory. This is the starting point of all mathematical thinking. In this series, we condense the essential ideas usually taught over a full semester into 3 focused videos of Kidesu series. You will learn definitions and properties of sets, functions, and relations with the propositions and theorems with a bunch of exercises. I strongly recommend that, especially for math major students, spend time solving these problems and practicing how to write rigorous proofs in their own words. This is very essential groundwork for everything that follows. In the introduction to analysis, we start from the axioms of the real numbers and explore how single variable calculus is built rigorously in mathematical language. We cover completeness axiom, the density of rational numbers based on this axiom, and the basic axioms of natural numbers, such as mathematical induction and well-ordering principle. Next, you will study sequences and their conversions, the precise definition of limits, and the epsilon delta framework. Mastering this material is crucial as it forms the foundation of all further study in analysis. In the introduction to topology, you will learn what a topological space is and why topology matters for calculus. The focus here is on understanding which kinds of spaces allows us to define limits, continuity, and integration precisely. We will look in detail at metric spaces and their properties, and these ideas connect to measure theory and integration later in this curriculum. This sequence is designed so that you can build intuition about the spaces where modern analysis takes place. Next, we move on to linear algebra. You will study vector spaces, basis, dimension, and how linear maps can be expressed as matrices. This series also goes further, exploring the spectral theorem in detail, a topic often studied in the third or fourth year of undergraduate math major programs, or even the first year of graduate school. The understanding and application of spectral theory have incredibly broad relevance: analysis, algebra, geometry, statistics, and machine learning. With linear algebra, we introduce abstract algebra. Here, the focus is on connecting linear algebra to group theory. You will learn about groups, rings, fields, and fundamental theorems such as Lagrange's theorem and the isomorphism theorems, while more advanced topics such as Galois theory or an algebraic geometry are beyond the scope of this Gidesu series. We plan to cover them in other videos on this YouTube channel. The main goal here is to understand algebraic structures and the language they provide. As you progress, you will explore multivariable analysis and the beginning of differential geometry. You will study the inverse and the implicit function theorems, Stokes' theorem, and the basic of differential forms. These topics are essential for connecting the abstract principles of calculus to geometry and for understanding how advanced analysis generalizes to higher dimensions. The final step into advanced analysis is measure theory, especially Lebesgue integration. You will learn about LP spaces, Hilbert spaces, the Radon-Nikodym theorem, and how the fundamental theorem of calculus can be generalized in more abstract settings in measure theory. This part of the series will give you a deep understanding of the analytical foundations that underpin much of modern mathematics and applied field. It is important to note that all of the Gidesu contents are not just theoretical. Of course, it's heavily theoretical for sure. The content you will learn provides the mathematical backbone of machine learning, statistics, and data science. Whether you are aiming for a career in research or industry, these topics will help you build real transferable skills. I strongly encourage you to approach the material carefully and with curiosity. Finally, I want to warmly invite everyone watching this video to join us. This series has been created so that you can build your understanding step by step from foundational set theory to advanced graduate mathematics. Already, many learners in South Korea are studying together through Gidesu study groups, and soon there will be opportunities to participate in English as well. I hope you will join us and discover the joy and depth of mathematics together. Thank you very much for watching this video. Bye bye.